All right, we are continuing on with exponent rules. So today we are going to talk about dividing. So let's write on here, dividing like bases. That is the title. So this is another problem string that we're going to do to what we did last time where we found a rule for when we divide like bases. All right, our first problem is 16 over 8. We can do this in our heads, right? What's 16 over 8? Yeah, 2. Let's rewrite 16 with a base of 2. So 16 over 8, but we're going to rewrite in the form of a base of 2. It's 2 to the 4th is 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then 8 is 2 to the 3rd. So we're rewriting it with the same base, like bases. And now let's expand these numbers out because this is going to end up equaling just 2. So 2 to the 4th means 2 times 2 times 2 times 2 on top. And 2 to the 3rd means 2 times 2 times 2. When you have a number over itself, if I take 2 and I divide by 2, what do I get? 1. So I'm going to use a highlighter and go over the top and put 1. It's really like we are simplifying those out. So when you simplify those out, now you just have 1 times 1 times 1 times 2. So all you have left is 2. What power would 2 be? To the first power, yeah. 1. Yeah, we can just keep it as 2. Yeah, that one does nothing. All right, let's do 64 over 8 this time. We know what this is, right? What is 64 over 8? Yeah, 8. Okay, so what we're going to do is we're going to convert this all to bases of 2. What is 8 as a base of 2? 2 to the, look over here, third power. All right, let's look at 64 over 8, but as bases of 2. So 8 we know is 2 to the 3rd. 64. 2 to the what power gives us 64? Let's see. Why don't we just use our calculator? 2 to the 5. No. 2 to the 6th. Okay, 2 to the 6th. All right, so let's expand it out. So 2 times 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2. we're going to do the same thing. If you have a 2 over itself, you get 1. 1, 1, 1. And remember, this is multiplying. 1 times 1 times 1 times 2 times 2 times 2. Let's write it out with the same base of 2. So what's left? 2 to the third power. So we're looking for patterns here. We're looking for rules. Okay, let's do 2 to the 6 over 2 to the third. So instead of expanding it out, do you see what we could do? See, what could we do with these exponents of like bases? If I add them, what do I get? 6 plus 3 is 9. So that's not going to work. What would I do if the exponent is 6 and then 3? How would you go from 2 to the 6 over 2 to the third to 2 to the third?
Can I try?
2. What do you mean?
All right. What could happen? What did we do? We took away pairs. So if you have 6 and you take away 3 pairs, what operation are we actually doing? Subtraction. So remember, with multiplying, we're adding. With division, we're taking away. All right, we're going to do some more. No worries. If you don't have it yet, that's okay. So a way to think about it is multiplying is repeated addition, right? What's dividing? Repeated subtraction. See how everything's related? All right, so let's just expand them out so we can look again at the pattern. So we expanded them out. Simplify. I'm just writing lines over the top of them now. What do we have left? 5 squared. So what could we have done? All right, let's do 2 to the A over 2 to the B. We can't expand it out. They have to have the same base. Like bases. So if these have like bases, so these both have 2's, the exponents we can just subtract from each other. So this would be 2A minus B. They have to be like bases in order to do this.
What if the bigger exponent is on top?
So if we have, well, let's look at that. If we have 5 to the power of 2 over 5 to the power of 5, it's going to be a negative, but let's expand it out. Because what does negative exponents mean? Expand it out. The bigger is on top. So what's left on top then? No? 1 times 1. So it'd be 1 over 5 to the third. So instead of the term being on top, it's going to be on bottom. Because if you subtract them, this is our next thing, actually. It's negative exponents. So let's just write the rule real quick, and then we'll come back to what negative exponents do. When dividing like bases, subtract the exponents. Okay, one other thing we're going to look at is if you have a negative exponent. Let's see. How about I just pass out the foldable? Y'all hang on. So you are going to cut out the paper like this. Fold this toward the center. And this toward the center. And then cut these. All right, so let's go ahead and look at quotient of powers. So we're starting at the top left. For any non-zero number a and any integer's element p, am over am p equals am minus p. So subtract exponents. We don't have to expand them out unless you want to, but expanding them out just proves the theory or the rule that when you have like bases, you subtract. So on this one, we have a G3 over an H5 and G3, H5, G, and H2. So we're going to just look at G's. So if I have an exponent of 3 here, what's my exponent of just the G? 1. So I'm going to do 3 minus 1. 2. So it's G2. And then H5 over H2. H3. And that's all you got to do. You leave it just like that. Okay, so let's go to some problems here. Go ahead and do the first two. All right, so we would subtract 5 and 2 because those are your exponents. So 5 minus 2 is 3. So it's 5 to the third power. Which, let's go ahead and find out what that is. 5 raised to the third power is 125. Okay, the next one, we have m to the 6, m to the 4. So take 6 and subtract 4 from it. M2. Okay, the next one, P5 and P2. Subtract those. What do we get? P3, N4, and just N. N3. A squared over A. Yep. A1 or just A? Okay, the next one. X5 over X5. X to the 0, which actually we haven't done that yet. But anything to the 0 power equals 1. It equals, we can actually just mark it out. Anything that you have the same of, top and bottom, can be simplified out. So all we have left is y3 over y2. Subtract 3 from 2, just y. We don't have to put the 1. Yeah, because it's just 1 times y, which is just y. All right, the next one. So we have constants on this one. We haven't done that yet. But we would just simplify that. Negative 2 over 14. Yeah, it's just 1/7 actually. Negative 2, over 14, negative 1/7. So negative 1/7. And then what about y? Y2. But you know what they're going to really want? Smash these together. And so on top, you just have negative y squared over 7. These are the same thing. All I did was put the y squared on top because it would be multiplied on top and take off the 1. All right, this next one. Let's look at the x. I have an x on top and an x on bottom. That's just 1. They go away. Y2, y6 over y4. Y2. All right. Let's look at this one. We have R, N, and T. So let's look at R. R7 and R3. R4. Yep. N7, N3. N4. T squared, T squared. 1. So we just leave it.
And it doesn't matter which order they're in, right?
Nope.
Or
Nope. Doesn't matter which order they're in. All right, the next thing that we're going to look at is our 0 exponent. Anything to the 0 power equals 1. So I'm going to show you. I can do 10 to the 0. This big crazy number, I just kind of typed in things. To the 0 equals 1. Anything to the 0 power just equals 1. So this equals 1, and so does this. Anything to the 0 power equals 1. So if you see it, you can just mark it out. All right, let's go to this. Ooh. This is 2 squared over 2 to the negative 3. What do we do with our exponents? So it'd be 2 to the 2 minus 3. Let's see. What is 2 minus a negative 3? There we go. 5. Because what happens to your minus and negative? Yeah. So this is 2 to the 5. All right, what about this? This is M1. So 1 minus a negative 4. M5. All right, this one, we have 0 on top. To the 0 power, yep. So what's left is just 1 over 4 to the W negative 1 y squared. But what this next, I'm going to show you what the next rule is, negative exponents. If you have a negative exponent on top, all it does is puts it on bottom. If you have a negative exponent on bottom, it puts it up to the top. You can change a negative exponent to a positive just by switching. If it's on numerator, it goes to denominator. Denominator goes to numerator. So this is going to go up to the top. So that means it's w to the first power, or just w, over 4y squared. I don't like negative exponents. Those are ugly. So I get rid of it by, if it's on bottom, move it to the top. If it's on top, move it to the bottom. All right, so we're going to pause right there and come over here. Because that's what the rule says to do with negative exponents. So if I have this negative exponent here, I actually need to just move it to the bottom. P8. And then P3. And since there's nothing on top, we just put a 1. P3 stays where it's at because it's a positive, but P8 moves to the bottom because you can't have a negative exponent. So then this would be 1 over, what operation do I do with my exponents whenever I'm multiplying like bases? Add them. So what is this going to be? 11. There's so many rules, right? It's crazy. All right, let's look at this next one. I have a b to the negative 4. Where does that need to go? To the bottom. On the bottom, I have b to the negative 5. So what do I need to do? Take it to the top. And now I'm dividing like bases, so what do I do? Like bases, what do I do? Yep. Yep, subtract those exponents. So 5 minus 4, 1. So this is just b to the first power, b1. Because it'd be 5 minus 4, which gives us 1. B to the first is just b. All right, let's look at this next one. X to the 4, and then x to the negative 2. What should I do with that? Yep, so I could actually do x4, x2. What about this y0? It just equals 1, so I'm just going to mark it out. So what do I get? X6. All right, next one. We have to get rid of this squared right here before we can move on. So we actually, what is that called whenever it's a power to a power? What are we doing to this? Yeah, we're going to send it in. So this would be 6 squared. What is 6 squared? 6 times 6. 36. And then a to the negative 1, I'm sending the 2 in there. So it's going to be a to the negative 2. And then b to the 2 over. I need to send the 4 in, like I'm distributing it. So that'd be 4 times 2, making it be 8. We're not done yet, though. 36 is going to stay on top. Where's the a squared going to go? The bottom. And what about this b? b2 and b8. Subtract them. What's 2 minus 8? -6. So where is it going to go? The bottom. So B6 will go on the bottom. Let's do 11 as our last problem for today. Anything to the 0 power equals what? What?
Or 1.
1. That was the easiest problem on this thing. All right, so your assignment is on Delta Math. Make sure you show your work.